Welcome. Today we discuss the topic Kirchoff's law in electronics. We know that there are two types of Kirchoff's law. First one is Kirchoff's current law and second one is Kirchoff's voltage law. Firstly, we discuss about the Kirchoff's current law. Having statement, the algebraic sum of the currents meeting at a junction of a network is 0. The algebraic sum of currents means summation of I is equal to 0. Then see the diagram. In diagram we see the 5 currents I1, I2, I3, I4 and I5. But some currents having direction toward the junction and some away from the junction. Means the current flowing towards the junction as positive. Towards the junction means current I1, I3 and I4 flowing towards the junction means having value is positive. Therefore summation of I is equal to I1 plus I3 plus I4 having positive values, and current flowing away from the junction as negative. Current I2 and I5 having directions negative, minus I2 minus I5. Then we can write as I1 plus I3 plus I4 is equal to I2 plus I5. Therefore I1, I3 and I4 is incoming currents, and I2 and I5 is outgoing currents. Okay. Then we can see the second Kirchoff's law, means Kirchoff's voltage law. See the diagram. Okay. Having statement, the algebraic sum of all the applied EMFs and the product of the current and resistance of each part of the circuit is equal to the 0. The algebraic sum of the applied EMF and the product of the current and resistance is equal to the 0. While by applying Kirchoff's voltage law to the closed circuit, we will have to start from one particular junction. We will start to one particular junction, then go around the loop in any particular direction till the starting point is reached again, means in this way. During this process we have to note down potential changes. Okay, a rise in potential should be considered as positive and the fall in potential should be considered as negative. While going from negative terminal of a source to the positive terminal, there is rise in potential, means while going from negative terminal of the source to positive terminal, there is rise in potential. Hence in this case EMF should be considered as positive. Okay. Then in other hand, while going from positive terminal of the source to the negative terminal of the source. There is fall in potential and the EMF should be considered as negative. And in case of resistor, if we go through it in the direction of current, there is fall in potential, because we know that the current always flow from the point at higher potential to a point at lower potential. So potential drop across the resistor in case should be considered as negative. Means in case of resistor and the current direction, we know that the current always flow from the positive to negative. Therefore, we will be considered as fall in potential. Then, by applying Kirchoff's voltage law to the loop A, B, C, D and A. Okay. Then first law, algebraic sum of the EMF and the product of IR. Firstly, A to B. Then first is fall in potential means minus E1, then plus I1 R1. Then B to C, having last positive potential means plus E2. Then minus I2 R2. Then C to D. There is fall in potential means minus I3 R3. Okay. Then D to A. There is fall in potential means I4 R4. Okay. Firstly, E1 is taken negative because we are traversing a source of EMF from its positive terminal to negative. Therefore, it is fall in potential. Then I1 R1 is taken positive because we are going through resistor R1 in the opposite direction of current. Then E2 is positive because there is rise in potential, and this negative because it is fall in potential. Then C to D, I3 R3 taken as negative because there is fall in potential, and I4 R4 is taken as negative because there is fall in potential. Thank you.